How about the chat? Jerry is first. How are you doing today, my victim? Ooh, nice. Woodville's number 2. Oh man, what I would give to have a U1. Oh, that makes me so jealous. Interesting. Isn't this lining? See how it's off a little bit? I wonder why. That means this is not square. Part of the problem. Having a problem with printed parts not lining up. Got the battery version. It fits perfectly, actually. Although I'm going to make it a little taller. The problem is the screw holes don't line up. Should. He seems to be doing okay. Once we got him back in the scooter, that messed me up yesterday, man. I tried to get a little bit of sleep. I tried to sleep in the car because I could fall asleep pretty quickly in the car. Maybe I'll get an hour of sleep before I start the stream. So wasted, I couldn't. I couldn't even think straight. I was so tired. I didn't wake. All right, as long as you're okay, that's what matters. Um, send Michelle. Bird. He's my neighbor. What else could I do? Leave him there. Maybe that's unusual for other people. Me, not helping. What kind of person are you if you don't help your neighbor? Unless he's the neighbor from hell, then you can eat him. But otherwise, it's just being a person, man. I got the hole size correctly now, so the battery fits. To make these walls a itty bitty bit taller. Fix the holes so they line up. Speed port hole isn't quite perfect. I'm gonna make it a little bit wider, but the switch hole fits perfectly. I'm gonna thicken up these walls a little bit too. Walls need to be just a tiny bit. But gotta fix this piece so it fits properly. Shell should be popping in a moment. Okay. Now, is there anything I could do to fix this? This. Now we're going to hide this. Well, they changed the icon. So this is not centered on this. It's probably a small enough amount that it doesn't matter for the most part, but I'm doing it. First, let's fix this while we're in here. So that's 12.2. Let's go 12.6. Let's go 12. The wings on the side of that unit are really rigid. Okay. Now, let's do this again. Is okay. Is that a separate piece? Yes. That's one piece. Okay. I gotta redo it later, but for now I need okay. Is off center somehow? Line. Yes, they are. They're off center by just a little bit. How that happened? Now I do this and this. They should be centered. Yes. And then if I do this and this, it should be centered. Yes. Okay. Now we're all centered. Okay. So I think the first thing I want to do is first thing I have to do is this. Let's Control D this. We're going to combine it with this, join it. Now I have this second copy merge with this. Okay. Now I can manipulate this one separately. Dismantle this a little bit. We can do that later. Let's just delete this for now. My corners. That's my central cutout. Yeah, if I fatten this up, fatten this bit up while not changing this, that'll help. I want to fatten it up without altering these. No, it doesn't matter. No, but I don't want to change the shape. There we go. That'll do it. Okay. Make this 49. This 50. Okay, that'll fatten it up a little bit. That's a through and through. I'm going to add a block on the inside. Oh, wait a minute. To do this first. Find this. This. Now I can fatten. 9. Okay. We still have an overlap. Can't tell. I think we do. Yeah, we still have an overlap. Okay. Take that later. So I should now be able to take this, this. Well, let's do this first. Oh, wait a minute. I have to split these first. I need a copy of this. These oblong? Oh, they got stretched. Oh, no wonder they don't line up right anymore. Oh, crap. When I stretched these, I stretched the holes too. Ah, no wonder that did that. Okay, that. These should be 4. The hell is the other measurement? Okay. Is it 4 or is it 3.5? 3. Give me the goddamn square. Jesus Christ, give me the fucking square. 3. Right. Now, where they sit doesn't matter as long as they sit in the same place on both. So let's do this. Not what I wanted. U and U. Control D. Nope, not Control D yet. To join them first. Then do a Control D. Lift the second set up in the air to join with the first set. U, and U. Add join. Actually, let's make sure they're centered. go. Now it's centered. Uncentered pair. D. Now we have centered pairs. This, this, join, then join this, okay. Now we need to read this line, this. We are centered. We are centered. You are going to get joined with this. Oh, why do you keep doing the bright red? Can't see anything when you do the bright red. Okay. That's right. I wanted to make it a hair taller. Can I get away with just doing it? I can get away with that. Let's add a small reinforcement square inside of this on the bottom. Make it a hole so we can see inside. This. Now, the whole point of this is to make sure that the switch screws have something to bite into. Okay. Now we can bring this in a little bit. Recess it a tiny bit. Since now we have this extra here to bite into. So we take this. I would like to radius it a little bit. Way to do that is to sit up 0.1. It's the height a little bit. Now we should be able to get away with radiusing it a little bit just like that. Yeah, that should be. This way it's just not so harsh. Fix that. That's 36. Change this back to 36. You and you line on center. There. That fixed our radiusing a little bit. I'd like that radiusing to be a little bit better. So let's do 6 by 6. Should not be out. It's not. So if we this by Z. There, gives us a little bit more radiusing there. I do it backwards. 2. There it is. That's what I want. That looks good. This and this, join them together. Okay. Now we take this, join them together. Gets rid of the pieces that are going to interfere with the insertion of the bits. Actually, that is way more complex than it needs to be. Yep. Let's get rid of the complexity that we don't need. That complexity will come back to bite us later. Okay. Take you. I'm gonna keep. Join. And make any other changes. Hey. That's it. All right, let's see what happens when I merge. Really? You're obsessed with that red, aren't you? Just obsessed with that red. Okay. I've resized this hole bigger. These are now properly squared, centered. I've deepened this and added a backing plate for it. These should still be centered. Hey, Michelle. That's a kind of hiding from you. They're over here. Okay, we do still need to make this 50 millimeters wide. Let's see here. Okay. Now let's start manipulating this piece. Okay. Okay, let's simplify. Should be able to simplify by taking this, this, and this. They are already joined, aren't they? Yep. These two. That. Should also be able to join this. Then also join these. Now we add nine. Now we're the same as the other one. Okay, now I need to adjust the screw holes. As you can see, what did I just do? That. Okay. See here, penetrating the wall. That's no bueno. Bad. Why didn't this join? Now, how come these? Oh, they are. Can't see it from the distance. Okay. What I need to do is move these outwards. And to do that, I have to do it down here too. Do I have any big holes, smaller? See how much wiggle room I have in there. Now they're both gone. They're in the kitchen. Yes. I definitely have wiggle room. Not a lot, though. I'd probably make it 1 millimeter smaller. I can get away with that. Okay. So let's delete one. Split this one. This one. This one. Okay. I can combine this with that going straight through? Why can't I? Oh, because it's joined. This we can join because it's not going to interfere. Side. Got the whole end. Yep. Okay. Redo this cap. Which means I need to make some changes here. So unhide. It's just an extension. Take this and we split it. How big is this? 12. Let's make it 11 by 11. Two of these. Wait a minute, first we need to split these. Again. Split them again. Take the two of these. And we align them on this one. Line here. Center. Center. Okay. This is still puncture. How much does it miss by? Oh, it's right there. Oh, I don't know if that's enough. I'd like to move 1 millimeter outward. Okay. Sure these are centered on each other. R, join. Okay. All right, let's do this now. Split. 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 Come on. Didn't know it was that far. Damn. Jesus, is that far? Okay. Split you. Split you again. Split you again. Let's do that. 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 And that. Okay. Join these 4. Right. Align with this. Shift a little bit. There and there. Okay. You're now centered. Duplicate. Lift. It's fine. I can just delete the extra. Okay. Here's our new centering pegs. I should be able to just take all this and join it. And of course, it's got a fetish for red again. Okay. Nope. Deleted the internal part. I forgot. I have to join this with this first. Hone out the inside. Nope. Do it. Got to be the orange pieces and the red piece and the clear piece. All those have to join. There we go. Now I should be able to just join everything. Why do you have a fetish for the red piece? You know something? Changing the color of that fucking red piece to something else. There, now suck it. And you still want to do red. There's nothing in here that's red. Oh, you son of a bitch. One last piece that's red. Why does it have such a fetish for red? And it still wants to do red. At least it's doing the right color now. Dang. Has it got a thing for red or what? Uh-oh. What's this? Oh, I know what that is. This has got to come up. Point one. There we go. Okay. That does it. back. Hide the battery. I almost forgot. This has to be this way. I do this alignment. This needs to come apart. It is. Okay. Double check. Sure we are still centered. Are still centered. Okay. Now it should be as simple as Control D, D, D. Align one on each. Line on you. Add here. Take another one. Align on here. Line. This one. Center and center. Line on this one. Center and center. Then double check, make sure this one is aligned. This one. Line. Center and center. Okay. I'm going to join these back together so I have them if I need them in the future. Stick them up here, out of the way. Now we take these and we join them as one. Join them with this one. Now let's see if we have alignment. I don't see no penetration. Good. Although I did want to make that taller. Just a hair. Okay. Let's turn off that. Stretch this. I like it. Center. Oop. Doesn't quite line up right. What the hell? Oh. Changed the wrong value. Huh? Yeah, that's getting closer. Yeah. Good join. Okay. Oh, come on. And okay. Okay. Now I need to put, what calls this? 25. Good. Hide you. I'm going to put a hole in you. back. 1731 by 186. Son of a bitch. I'll stop moving. Okay. So if I want 4 perimeters, 4, 8, 12, 16, so 2 millimeters. So I need to be millimeters on each side. First, let's make it 17 to make it an even number. So I need to make it 1.6 smaller. I think 3 would be enough. So 15.5 and 14. And we also need length smaller by at least 2 millimeters on each end. Let's make it 180. Now we just do a recline. Take this and shove it right through the ass of the other piece. That. Oh, I don't want to do that. Definitely don't want to do that. That. Go away. Got to come in this way. This way. Plane here. Up. Take these 2 pieces, and punch a hole through this piece. Point it. Not what I wanted, because you're an asshole. Won't let me do it, will you? Okay. So I need to take 05 off. 131.95. 1, 5. 131.9. Now I should be able to join without the edge cut. There we go. I was having a problem with this bridging. So that's how we're fixing it, by getting rid of the bridge. Then should also be able to get rid of some of this arc here. This is getting difficult to do because this program is being an asshole. Need to flip this. Does shading. I couldn't see properly inside here. Okay. If I take this here, play that. And you chop. That didn't work. Dummy. Forgot about the fact that it's going to do this. And I still didn't get it all. Are you kidding me? Ah. Come on. Why? Man, can it be a nudge sometimes? Like, you really gotta mess with me like that? Bend you, line, you, center. Oh, and it let go again. Why does it do that? There. Dick bag. 131.9. 9. 2. Okay. This and this. Up there. There we go. Now that will print a lot better. Because I did that. Solid, right? Yes. I shouldn't have done that. But anyway, I'll then treat these as two separate objects when I print it in the slicer, and that'll cause it to do a clean bridge across here, across all the layer lines. I'll show you what that does once we get in the slicer. So it's at 25 millimeters exactly. I can join this, rotate this around. Something tells me this is not connected properly. Is it not connected, or do we have an overlap issue? Oh, for Christ's sake, come on. Huh. It's slightly too small. Really? I didn't expect that. It's slightly too small on both ends? Yes, it is. That's okay. It's probably below the threshold of the printer resolution, but I could probably fix it. Hello, Sun Turtle. One more. Of course, it's not. It's off the screen. Okay. Another alignment. See what that looks like. Tiny bit more. I'm in here doing detail work. I might as well do it all, right? I think it's going to be pretty cool. Especially the this one here. because this one here is the one that's going to be powered off the tool batteries. As you can see, the head of the of a tripod will fit right in there. This is super lightweight, doesn't weigh much. So the way this one's going to be wired is these need 3 to 4 volts each. So I'm going to do some self current limiting. I'm going to wire this in a 6S2P configuration. So 6 of them in series, 6 of them in series, and then the 2 sets of series in parallel, run down the wire, hook it directly to an 1820 volt tool battery. And that way it will not be over bright. But that'll be super lightweight. Just weighs nothing. It's just not, it's like 150 grams plus the whatever the weight of the wires and the LEDs are. And then for a self-powered model, this one. This one will have USB charging with the switch. I haven't figured out how I'm going to make it brighter and dimmer. What I think I might do is put a variable voltage thing. The problem is finding one with a fine enough resolution that get usable differences in brightness. So I actually have one here. I'm going to test, see how it works. But this one would be nice. You can set it on a table. You can get one of those little tiny tripods and put it right in the middle of a camping table. It's all self-powered. Or you can use the tool battery one if you want to use tool batteries. Hey Cassandra, how are you doing today? So now let's see if we are aligned. Oh, we need a little bit more. 17.35. This is kind of anal getting at this because that's well below the printer's resolution. But I don't care. In here, might as well do it, right? A bit more. A tiny bit more. Are you kidding me? We're gonna go 2. And watch, it's gonna be too much. 38. And it still needs a tiny bit more. We are so far below the resolution of the printer. I did. So this is the UFO. So that just sits right on top of a tripod. This is the one with the built-in battery. This will sit on top like this. There you go. That'll be your complete light. All the lights will be inside here. So this is the standalone self-powered. The other one is for powering off tool batteries. This is the dome. You want them all angled out and down because you want to light up down below. You don't want to light up the sky. There's no point in lighting up the sky. That is as close as it's going to get. Yeah. And I was right. There's a gap, even though there shouldn't be. See, this is just that weird thing Tinkercad does. That gap should not exist. Well, it's one big battery. It's one big, gigantic battery. So, that's the battery. It's a very, very large battery. That is a 20 amp hour lithium iron phosphate battery. So that'll run this for like 2 days. Well, you wouldn't want to do that with this. You would do that with a very small lipo, because that lipo would only run the lights for maybe 10 minutes, but that's the long as your drone battery is going to last, so it's good enough. No. I mean, I could, but there's no space. But there's no need to. All these are shining down. So the idea is, like you get those short little tripods, like your microphone sits on, get one of those and stick it in here. Or just sit this right on top of the table. But a little tripod would be perfect. A little bitty tripod like that tall. Just enough so it lights up the whole table. Or this is designed with holes on the end here. So you put two little screws on the end so you can have a string hanging from here, and you can hang this from a hook or a magnet up inside your tent, canopy, or your cabin, or inside your house. You can hang it from something to hang it up higher to get light. Power outage, for example. We already have that. The 3 meter pole is right here. Yep, we did that. So this is the 3 meter pole. This pole will extend 3 meters. It's got a built-in tripod. And the way this one works is the top rotates. Top here rotates to lock these lights in place. Okay. Bit fiddly. Oh, missed one. Missed one. Oh no, it popped out. I never seen it do that before. Surprised it did that. Huh. It actually ripped the filament? Oh no, it just pushed it out. Did it? There we go. Oh yeah, it ripped the filament. Whoa. I've never had it shear the filament before. That's impressive. That's like genuinely impressive. Push that in a little more. No. I haven't figured out an elegant solution for lining all the pedals up. Not have an elegant solution for that. Kind of got to just get them in the right position. Oh, go and tighten that down. Now the pedals lock in like that. Then you flip the switch. The whole thing lights up. And the whole thing runs off of one of those cool batteries. I have a variac on this one, a potentiometer, so we can actually dim it, make it brighter. Not much range though. Yeah, that'll light up an entire area, a couple hundred square feet. That exactly for making camp, a work site. That works really well. The whole thing folds down like that. So it folds down nice and compact. That's it. Have your camp light or work light. I just see them selling them for thousands of dollars for big ones, and even $200 or $300 for small ones. I was like, we can make one for well under $60. You buy that tripod for $40 on Amazon. Can go cheaper if you want. If you only need 7 foot tall, you can get a 7 foot tripod off of Temu or AliExpress for about $6.25. It is very cheap, but it will work. And if you still need 10 feet tall, for about $12, you can get a 3 meter selfie stick. Find that with a 6 foot tripod, and basically you take off the extensions from the tripod, just use the bottom, and you have your 10-meter pole or 3-meter pole for $20. But I think you should just spend the 40 and buy the better quality 3-meter tripod from Amazon. Well, that's why. Well, for the big one, I'm using tool batteries. So for like $25, you go on out, AliExpress, and you buy a 12 amp hour tool battery. It'll run it all goddamn night. I mean, it'll run that well, maybe not all night, but about 6 hours. You should probably get 5 or 6 hours from this at full brightness. Then, of course, you could also double battery. So you can hook up 2 of those 12 amp hour batteries, and now you got 10 to 12 hours of runtime. This one should run quite a bit longer. Well, if we could actually run these at full power, about 1 hour. Because these at full power would be 60 watts. Um, but since we're probably going to be running them at about 60 or 70% of full power, this should run for 2 to 4 hours, depending on the total brightness. That's why I'd like to be able to adjust it. Turn the brightness down to run it for a whole lot longer. Don't need it to be ludicrous bright. So I'm thinking about trying to parallel 6, and then series. So do a 2P6S configuration, or no, 6P2S configuration. So basically, you can either run all of them together for maximum brightness, or run 6 in series for half brightness, since you'd be cutting the voltage down in half. But the problem is the voltage might go too low, it might turn off. I don't know, but I'm trying to figure out a simple way of having like 2 brightness settings. I'd like to. I'm probably gonna have to just run it through a Such a pain in the ass. But I could run it through. I might be able to use the LED driver, run 6 of them, and have a second LED driver for the other 6, and basically run them in Firefly mode. That would still be enough to light up an entire camp table for like reading and stuff and eating and stuff like that. That would run for probably a couple of days. And then if you put it in high power mode, you might only get like an hour or 2, but it'll get really, really bright. That might work. That might work. I'm going to have to test that. That just might work. Okay. So this is done. I can now oh no, forgot we have to make this little change here. I have to get rid of that gap. So why is the gap there to begin with? Stop doing that. See how there's a little gap? Look, there's an actual literal gap that should not be there. Now if I do this, it's so small it won't let me. Hide it for a second. Hide it for a second. Oh, Christ's sake, go away. Why does it jump inside like that? And now it won't let me do it. Won't let me plop a plane down. Oh, what a pain. What am I doing? All I gotta do is hide this. Now I can plop a plane down here. I should be able to drop this. But I don't think it did it. In order to drop it, I'm betting there's still a gap there. Now, in this particular model, it's okay if there's a gap. It still annoys the hell out of me. Did you get rid of it? Why aren't these aligned anymore? They get moved somehow? It says they're centered. No, it looks good. Looks like I got rid of it. Okay. See what happens. All right. Hey, Lightspeed. Oh, your name got messed up. So, bottom, export. Yeah, YouTube did something where people have, you have to use like your real name now, and there's a different way to change your name, but there is a way to change it. We are making LED light arrays. So I came up with this. So here's, well, first back step. Where is, so you ever see those little keychain, the little square keychain LED lights? USB-C charging, it's got a little clip on it, and it's got a square LED on it. It's like a little flashlight. Well, the thing is, they make those by the millions. Literally, they make millions of them because they're $2 a piece. So they started selling the excess parts from those lights, including the little cobs. These are the little cobs. This is 6 of them. You can buy these so cheap, it's stupid. We're talking, I paid $2.19 and I got 20 of them. They're a little bit more now, so now it's like $2.60 to $3.19. So about $3. You get 20 of them. And you can buy them in larger quantities too. I've seen them as large as 200 at a time for 12 cents each. 12 cents a piece. And so I was like, what can we do with these? So you know I have the flashlight I've been working on. So that's the 2 lights in the front for the flashlight, USB-C charging, side light to light up your table. So what else can we do with them? So I came up with this little hat light, this little UFO hat light. Now I haven't wired this up yet, but it's just a simple little hat light that they'll screw into a tripod. Uh-oh. Well, you better not give me a problem. You better export that file, bastard. And so there's 12 of these on here that I could fit inside of a, a bamboo print area. Ender 3 print area, bamboo print area, A1 print area, whatever. This is light too. This is like 150 grams. So you can put it on top of any tripod you want. The way I'm going to wire these up is I'm going to wire them up 6 in series, and then take that 2 6S configurations into a 2P configuration and run that down and power it off of a DeWalt tool battery. So you'll have one of these sitting at the bottom of your tripod and it'll power this. And then connect it with a little potentiometer and you can control brightness. I also have a self-powered unit. So this one, I still have to wire it up. But it'll be 12 of them all in parallel because it'll be running directly off of a battery and USB-C charging, switch to turn it on and off, plenty of space inside to dick around with it. We're just making some final changes. But all these things run off of these batteries. These are called C40s. They're about 186 millimeters long, about 180 long, and 40 wide roughly. But the cool thing is, it's a 20 amp hour, so that's 64 watt hours, or 20,000 milliamps of lithium iron phosphate battery, which means it'll last forever. She's doing okay. She just got the flu or something, and so she's been real sick the last couple days. Like, I watched her try to eat a bite of dinner, and she just puked it all out. Oh, that sucked. But it's just getting over it. It's one of those bugs. It's running rampant through the entire facility. But yeah, so all that will be in there. Battery will sit on top, of course. This one will be self-powered. I'm trying to figure out how to create different brightnesses. I need to find a small potentiometer that'll allow me to adjust the power. Something that'll allow me to create multiple brightnesses. So all the errors that I discovered, like it doesn't close all the way, the holes didn't line up, this hole was a little too small, this is not quite recessed enough. So we're fixing all that now. Yeah, just all different things I can come up with to do projects with these, because you can get them. I see her once a week. Every Tuesday I go down and visit her. It's a 70-mile round trip, so it's a lot of gas. Yeah, I got a whole mess of these lights. I'm gonna get more. It's because they're so damn cheap. I was supposed to stream yesterday, but I was wasted. I couldn't do it. My neighbor called me at 5 o'clock in the morning. That, like, dude, really? Like, come on, you're stuck in a mobility chair, and you're gonna go outside at 3 o'clock in the morning and dick around with the skunks? He fell off the mobility chair. He had to crawl back inside of his house to get to a phone. Like, dude, don't do that. At least do it on a when it's not 25 degrees out and you're not going to freeze to death if you get stuck outside. So I had to go over and help him, and it took us 3 hours to get him back into his chair. Everybody using peptides lose weight. Peptides plus. What do I think? I have no thoughts whatsoever. I have no idea what you're talking about. Peptides for weight loss, such as semaglutide, Wegovy. Oh, these are the GPL1s. Yeah, the GLP-1 stuff. This stuff. I think it's fantastic. The doctors love it. They say it's one of the first weight loss aids that actually seems to work, and I can't get it. Yep, I can't have it. I'm only 480 pounds, and I can barely walk 50 feet, but I can't have it. I'm not sick enough. Yeah, basically my A1C is still too good. It's like, wait a minute, I need to be worse in order to get approved for it? Really? That's just fucked up. Like, what the hell? Okay, that downloaded. Right, top export. But yep, my A1C is still too good. It's 6.5, which is in the pre-diabetic range, and it's going down. I'm slowly getting it down. Um, that's all good. Holes line up now. 3D Medic, how are you doing? Okay. He beefed up switch backing so it has something to bite into. We corrected it and aligned the holes. Yeah, well, I don't got $200 a month. That would be 50% of my income. I can't do that. I mean, I don't even know how the hell I'm going to pay my electric bill this month. It's $242. I ain't got it. It's not yet. Why is that so dark? Oh, it's just an angled wall. Doesn't quite line up, but it's fine. So if I don't have the money, I can't get it. So insurance doesn't pay for it, I can't have it. Rounded off these corners, so the print cleaner. Fattened up the insertion point for the USB-C port. Deepened the cutout for the switch. Widened and lengthened the battery cavity just a tiny bit. And I also formed some geometry trickery to allow this to print better. I will show you that now. Bring up the slicer to correct the files, just to make sure they're clean. Come on. Right, take the bottom. One shell, 220 errors, fixed by Windows algorithm. Let's see, export. Bottom. Top. One shell, no errors detected. Righty. Alrighty. All this. All this. Let's bring up recent factory. This one. That. Okay. Watch this. This is a neat trick. First, I bring the part in twice, so that they sit right on top of each other. I then group them, so I can treat them as one object. I'm going to give it a 45-degree Z rotation, just to keep it further away from the edge of the bed, so the heat bed will keep it from warping. This we are going to modify. Set this to use the first model, the custom zone that goes, oh, I almost had it right, 25. Save. This is going to use the second model, custom zone starting at 25. Save. Then turn off the additions, try printing it, and we see what changes I need to make. No, they don't require support, because the one part's being printed in midair, so it thinks it requires support. Why is it doing that single line? That's weird. I can get rid of that. So total height, it is 2.35. So we stop at 27.25. Just to get rid of that little line on top. Oh, now here's the magic. So it's printing the base. Then when it goes to print this, print straight across the whole thing like that. No BS to get in the way. It's 1, 2, 3 perimeters. Actually, I'm going to change that. Do I need to? 1, 2, 3, 4, 5. I probably don't need to change that, but I think I'm going to anyway. Because if I change this to 2 perimeters, bridging overlap will be better. Tinkercad is just very visually oriented. So as long as you understand that the parametric nature of modeling, you have to do in your head. Because Tinkercad itself isn't parametric. As long as you remember that and you can organize the steps in your head, then you can do some pretty amazing things with Tinkercad. And also using geometry to make some pretty impressive things without. Do I have thin wall? I do have thin wall. Oh man, I want to get rid of. Okay, so to get rid of that, I know what I need to do. It's just a pain in the butt. Okay, so that's thin wall right there. Okay, 33. And what layer height am I using for this? 2? Is it 0.3? It's 0.3. I want to learn SolidWorks because they do have a hobbyist home version for how SolidWorks. And even though I don't like renting software, the cost to rent SolidWorks for the rest of my foreseeable life is still a fraction of what it would cost to buy it. And so if I'm gonna spend the time to learn a program, I think I'd rather learn SolidWorks. Because I don't think SolidWorks is going to keep taking features away. Plus, you can download SolidWorks. Let's see. Calculator. Come on, open the damn calculator. What is this thing doing? It's crashing is what it's doing. Something's crashing. Three finger. Can't even three finger it? Oh yeah, it's hard crashed. I don't even know if I'm streaming anymore. This is Windows. Windows, this PowerShell. Windows has been crashing on me lately. Task Manager. Hey, it finally caught up. So what's taking all the memory? OBS is 63%. Firefox is 2 gigabytes. Jesus. Got plenty of memory though. Just had to wait for it to catch up. Calculator is not loading. All right, 33 times 0.3 is 9.9 millimeters up. So what we doing. Okay. Let's do this. There. Stop messing. Right, align on you here. Oh, I'm not showing my screen. Nope. It got reset in OBS. Okay. Need to go up. Of course it's off the screen. What else would be new? 9.9. Okay. So that's the point at which it begins to switch to single line. So what we do is we chop a chunk out of it. Yes. Just like that. All right, let's hide these two. Actually I have a tool. I have these up here. Yeah. Let's separate these. Good. You and you. Going to align on you. Center. Here we go. Now we take Control D and align it with this one. Line, you, center. Okay. Now we take these two, join them together. Duplicate them. Bring them over here. Go. So by taking out this little notch, we'll stop that single line behavior from happening. Single extrusion, which will make it look a little odd if you look closely. But if you don't look closely, it's just going to print better. But by taking that little notch out, stop that stupid single line behavior that causes problems. So export STL. Okay. All right. Now we parts. Downloads. Tabletop 1. Drag. And drag. And we going group them. 5 degrees. Reassign the profile. That goes to part number 1. That goes to part number 2. Slice. Okay, we have our brim to hold it down, and as you can see, we have no thin line behavior. So it does variable extrusion. That's this dark green. But you notice it's not doing any of the dark blue. It always fails. It never works properly. Now we have a nice clean extrusion. It'll print a lot better. I would love it if I can get rid of this green and have a single come through here, but this wall would have to be thickened up quite a bit. We'd have to go down 3 more layers. Get to this one down here. Which we could do, but I think it's a point of diminishing returns at this point. I'm happy enough to get rid of the single extrusion. And because I made those cap cuts into this, you'll see here. Okay. So it's going to print top layer. Actually, I can get rid of some of that. Speed up the print a little bit by having just one top layer. So, problem is cleanly bridging this. So the first thing I did is I put a hole through this. And then I put a bevel on this edge. So now we don't have any of those extreme overhangs that cause the filament to let go. And then we go to a vertical wall. So we have 5 layers here, 6 layers. That's 5 layers. That's a consistent vertical wall. Then we have 1, 2, 3, 4, 5 perimeters here. And when we go to the next layer, we only have 2, which means we do a full bridge from here all the way across. See, the problem is if you bridge from here across, if it doesn't grab the end of this, it droops. Now that I'm doing a full bridge across, boom, no more problems. It does a clean full bridge just like it's supposed to. One thing I would like to fix is the infill angle is wrong because the part's rotated 45 degrees. So we're going to rotate the pattern 45 degrees to compensate for the fact that we rotated the part 45 degrees. Okay. All right. Which shouldn't affect the bridging. There we go. That's what I want to see. And we still have our bridge identification. Oh, no, 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 no. I don't want 2 separate parts. That'd be silly. Having 2 separate parts for this would be crazy. The whole point of me doing this geometry is to make sure that bridge works correctly. Problem is, it's a dome. The problem is, inside here, see how it's all sloppy? I already ripped out most of the parts that had came apart there. So the problem is it was a sloppy bridge. And by adjusting the geometry of the part, you can force the slicer to create a clean, strong bridge. And that's what I did here. What I want is for it to go straight across this opening, and I want it to overlap multiple of these perimeters. That's what we did. Perfect. That will print really, really clean. And the only reason I'm going down to 0.1 millimeters for this part is because that results in a nice, clean, smooth top here. It results in a nice, clean, smooth top. It feels nice. At 0.1, I'm pleased with that. Yeah, I mean, this will come out great. What I'm doing now is I noticed that because it was using single extrusion to print that little part right there, we got rid of that little part right there by doing this. See? No more single extrusion. Well, no more thin extrusion. You have single variable, that's the dark green, but no dark blue. I could make this deeper and get rid of this altogether, but I think this will print fine. So by putting that little notch in there, we get rid of that ultra thin parts here. Because you want to try to, I mean, the thin blue, the dark blue line is good when you have to have it. But if you notice that you're having problems slicing, where just certain parts of the model don't quite come out right because it's a difficult bit of geometry, see if you can modify the geometry of the model to compensate for it. So that's what I did. I can show you a cutaway so you can see what I'm talking about. Yeah, that'd be easy to do. Hang on. See here? Normally, this would be a dome because it's a cylinder. It would be shaped just like that right there. See? Right there. And the problem is that those domes don't print well, even at really low layer heights. The same thing applies in bamboo slicer. It's going to have the same problem. So the first thing I do is I stop the dome before the overhang angle becomes too extreme. And then I create a straight up bevel, which is very easy for the slicer to do, the printer to do. And then I create a vertical. I did that by cutting a hole out of here. And then by making sure this line right here is at a precise height of 25 millimeters, it's very easy for me to find that in the slicer. So when I go to the slicer here and I want to create my dual variable heights here, it's very easy. Because I know it's at 25 millimeters. So I don't have to do any math and go hunting for it in the slicer. Like I did here, I had to figure out that this was 9.9 millimeters. So by doing that cleanly in the CAD program, I was able to make it very easy to adjust the slicer, compensate for this. And so just by creating this geometry here, this will now print very, very clean. And because the dome is here, so the top of the battery is going to be that curve right there, there's a gap between the top of the battery and the bridging. So even if my bridging does droop a teeny tiny bit, it's not going to interfere with the battery and interfere with your ability to close this lid. So all of this geometry change is just changes I made in the geometry of the model to make it easier for you as the end user, meaning you'll have to do less work because this geometry your slicer will recognize and be able to more correctly slices. And when I say more correctly, I mean more compatible with the physics of 3D printing. More compatible with the way the nozzle moves, with the way filament extrudes. This is what you'd call printer friendly geometry, where it's not so much where I just add supports and crap. This is where I design the part be friendly to the 3D printing process and the slicing process. So the result is a part that just prints a lot better without you having to do anything special. I could probably make this even better having this arc continue all the way up. But I'm gonna leave it alone. I'm happy with the way this came out. But yeah, now this will slice a whole lot better. Same thing down here. I curved this edge a little bit so that it's not a sharp point. This way, if it tips over, it doesn't bump you in the head and hurt you. I rounded these corners, which looks nicer and prints better. I beefed up this a little bit here so that the screws for the switch have some plastic to bite into. What I should do, but I'm not going to because it's a real fucking pain in the ass to do this Tinkercad. Well, I could do this edge, but I should bevel all these edges. Put a chamfer, like at least this line right here and this curve and this line. If I chamfered these edges, it would work a little bit better. But doing that in Tinkercad is really hard. I mean, like really, really hard. Outside edges like this, easy. Inside edges like that, not easy. Again, this is angled to avoid those sharp corners. Yeah, that's all. I fattened up the walls a little bit because they were a teeny tiny bit thin. Not bad, but a little bit. Recessed the switch a little bit. The USB port was cracking the plastic when I shoved it through, so I widened it by 0.5 millimeter. That'll hopefully allow it to pop in without damaging anything. Sockets are an almost perfect friction fit. These diamond holes in the back are to allow cooling, to allow the back of the LEDs to be exposed to the air. So hot. We're going to be undervolting them, so I'm not worried too much about heat. You could also add some thermal paste and some heat sinks here if you want to. These holes are for zip ties. So if you have excess wires back here and you want to do a little wire management, run zip ties through the holes. On this one, for example, I have zip tie holes here and here on all 4 arms so that you can zip tie cabling. Oops, I just lost an LED. No idea where that went. And then you also have the holes here. So for example, I can punch the zip tie through the hole here, then run it back through that. Oh, so now you have a place to zip tie your wires around if you want. You probably want to use a smaller zip tie than that. It's a pretty big tie for that. Where did that light go? I don't know where that light went. Pretty big square. I don't know where it could go. Worried about it ending up in my foot. It's a sharp piece of metal. Yeah, there's no chamfer in Tinkercad. You need a better CAD program for that. Yeah, I know. Seriously, these things are LEDs are pretty sharp. Kind of worried about the fact that I can't find it. Nothing here. Go in the bag. I don't know where the hell it went. It's gone. The black hole of Planet 9 took it. It's gone. um, because I planned for other people to print this, I want to make it as easy as possible. And so that should do it. In fact, I wouldn't be surprised if this would print okay without me having to do multi-process. We're going to test that. Let's try this here. So let me export this. Stop. Table light. Stop. So it's incredible when I drop something and it's like, my floor is not even a mess. It's like there's nothing here. I got a bag, a heater, a printer. It's like, where did it go? It's not like it's a little screw. It's freaking 30 by 30 millimeters. I mean, where did it go? Probably went under my chair. When I get up and move the chair, that's probably where it's going to be. Or in the shoe. Landed in the shoe, too. Let's see here. Save the factory file. Okay. Now, just for shiggles, let's see what happens if I slice this as a single unit. I bet you it works okay. Yeah, not as good as I want, but that's not a bad bridge. Not great, but not bad. Now, see, here's the reason I don't like doing it this way. So look at the way this is working here. 1, 2, 3, 4, 5. So we have 5 lines here, right? Do I actually have 5 lines, or is that... Yeah, that's the outer perimeter. The outer perimeter is blue. Okay. So we have 5 lines. Next line up. See, the bridge is only sitting on top of that inside one line. So it's only overlapping a single line. See? Single line. I'd like that bridge to go all the way out to here. And with the way I did it, it does do that. It goes out to here. It goes out to this line right here. Which means it's a better attachment. It's less likely that this is going to fail to attach to this. And that's also why I want that wall vertical. It's another reason why I did that. Really? Come on. That's another reason why I want this vertical wall here. Because that vertical wall means it should be more solid. There it is. This vertical wall right here. This should be a well-established line by the time it gets to the bridge. Well, it's silver. The carpet is khaki. It's going to stand out like a sore thumb. It's hidden. It turns sideways, so it's like edge on. It's hidden behind something. It probably went underneath my chair. It's amazing how far these things can bounce when they go to hide. So while this theoretically should work, what I did will make it work better. That's all. It just enhances it. Okay, let's do the bottom. Bottom is a much more simple print. We just print it. I don't have to do any special geometry. Okay, let's delete excess. Let's get this modified, named what it's supposed to be named. Okay, bring this in. Make sure it slices good. Okay. That's a solid 4 walls with a fat fill in the middle. I'm good with that. That looks clean. Threads look clean. There's a little bit of thin behavior here, but I'm not worried about that. It's just one line. It's not worth trying to get rid of it. What I would have to do is go into Tinkercad and lower this by 0.3 millimeters. Get rid of that, but I'm not worried about it. It's 2 little tiny squirts. This looks good. Nice recess. This fattened up real nice now. That's good. 1, 2, 3, 4, 5, 6 perimeters right there. I'm happy with that. That's what I wanted. I have it set for 3 perimeters. So 3 on the inside, 3 on the outside gives you 6 total. So that's a good thick wall right there. Okay, I'm happy with that. No interference for the lights. Yeah. I am happy with that. That looks good. All right, there is one more change I'm going to make to this file to improve printability. Delete the bottom. No, I don't use supports. That's the whole point of all that geometry, is to avoid the need for supports. That's the whole point. Okay. I'm going to put a square here, out to here. This is going to be 0.02 millimeters. Line, center, there. No, they'd be easy to get off, but they would double the print time. We're going to move up 0.3 millimeters. You tell what I'm doing here? Oh, this is off. What I'm doing here is I'm putting, and a waste of material that you don't need. But then your top layer will be cleaner. And so what? you're wasting more plastic in that support material than you are in the slightly sloppy top layer. Like, screw that. Now, can you see what I'm doing here? See how I put that little cut in the model right there? That little cut only goes through one layer. It's 0.3 millimeters thick, and it's a width of 0.02 millimeters. The whole purpose of that is to change the behavior of the slicer when it does the first layer. So, when your most important part of your model is the first layer. Nothing is more important than the first layer. Because if the first layer doesn't stick, nothing is sticking. Part is going to release from the bed if you do not get a good first layer. So what is the bane of a first layer? Retractions and moves. So nothing's worse than printing this here, and then it goes to print this little circle here, and the circle doesn't stick to the bed. Now you got to stop and start all over again. Because if that circle doesn't stick properly, this is going to get all messed up. So I fix that by adding a little cut. Oh, wait a minute, we got to go into Crucial Slicer first to run the correction algorithm. Waiting to see what I did. Yep, 192 errors. Fixed by Windows Repair. And export. Bottom. Now we take that, bring it into here. Now, before when we printed this, you would have to print this outside perimeter, this perimeter, this perimeter, and this perimeter. Actually, that means I need to make one more cut. I almost screwed that up. One more correction I gotta make. Okay. Outside, side, over here, over here, over here. Okay, yeah. I gotta make one more little adjustment. This has to go all the way through. There we go. Exactly. It's inside the battery compartment. And not only will this make that bridge more successful, but it'll look better too. All right, I got to do that. There we go. Yep, I almost screwed that up. Let's delete the bottom that I already downloaded. Export. STL. There we go. Right. The one. Now, right now, if you were to print this, you'd have the outside perimeter, this inside perimeter, this inside perimeter, and this inside perimeter. That is 1, 2, 3, 4 separate prints that it has to make in order for that first layer to be successful. What I just did was reduce that first 4 separate prints to one single extrusion. Basically, I made the perimeter of the first layer vase mode. And that does this. Wait a minute. Oh, I almost forgot. Probably will be fine, but I'm going to correct the model anyway. Just to make sure nobody's slicer has any problems. Fix. There we go. Now watch what happens. You're going to love this. At least I love it. See what I did? Now when it prints the first layer, there's only a single travel move for the whole print. And that's for the first perimeter. And that's to go from printing this skirt to printing the first perimeter. Because let's say we start here. It's going to print the outside. And then it's going to come inside, print this part here. It's going to come inside, print this half. Come inside, print this part here. Come all the way around. Come back, print this half. Come back, print this half. And then meet back up at the outside again. So now that first layer is one single extrusion for 100% the perimeter of the model, which dramatically improves the probability that it's going to lay down correctly, especially little details like this. So instead of having to stop, retract, travel, and then extrude this, it's one continuous non-stop extrusion. The only time it's going to jump is when it's printing infill. But by then, the perimeters are already laid down and you're good to go. But it'll make that first layer cleaner, more reliable, and far less likely to fail. Meaning, as long as you make sure that it's extruding when it first starts, all you got to do is watch it make that first extrusion all the way around. And as long as it gets all the way back to the beginning again, likelihood of failure at that point is very, very low. I could probably even get rid of this brim a little bit, but I'm not going to. What I am going to do is increase the offset of that. It's giving me a hard time letting go. We're going to do a 0.2 millimeter offset. Ew! Oh no, that's the rest of the model. That's the rest of the model. That's fine. I was like, what the hell? Do I have... Oh, this needs to be changed. How'd that get turned off? That should never have been turned off. 40, 80. Huh. I wonder why that got turned off. Well, it's showing you the retractions and much better. Much, much better. That's what it's supposed to look like. You want to avoid crossing open spaces. This way, if you ooze, you're oozing inside the model. And number two, being in contact with the model should reduce the oozing. Much, much cleaner print. Okay. So the blue and the green is the model. Red is the travel moves, when it has to travel from one place to another without extruding plastic. And then the blobs that you see, such as... It's pretty good at hiding them, but they're there. There it is. See that blob right there? That's a retraction. There's blobs here, retractions. Good. And only takes 161 grams of plastic. I am A-okay with that. Yeah, I am absolutely okay with that. Yeah, 12 hours is about right. Exactly. Well, why waste plastic if I don't have to? 50 and 10, yeah, that's fine. I can always speed it up on the printer if I want to. But I don't mind taking longer if it results in clean. I'm okay with that. I do wish I could bevel these a little bit because I keep getting a little edge work here, but it's such a pain to bevel. I could do this pretty easily. That would be pretty easy to do. And this down here would be pretty easy to do. This curve part in here, that curve part's a real pain. You can try it. I mean, the model's pretty refined at this point. Although what I really need to find is a I need a voltage potentiometer. I'd really like to be able to control the brightness, but I need a potentiometer that's got fine enough resolution to be able to oh, come on. That can because I'm only talking about, 0.2 volt difference. I'm running this thing at 3.6 to 2.5 to 3.6 volts. So I need something that's going to 3-volt potentiometer. Such a thing exists? Is that what it is? It's a variable resistor? See, that's the problem. I don't know what I need. No, I might do that for so there's 5 amps. That's not enough. 10 amps. There's 10 amps. How's this? No, you have to design it in Fusion to be able to bevel it. See, I don't know if this does what I need. I think I need a I suspect I need something like this. A variable resistor. You can import it, but then you won't be able to bevel those edges, because those edges were not constructed in Fusion. How do I do this? What do I use to control the brightness of a 4-volt LED? My instinct tells me I need something like this. But I don't know, and I also don't know what range. Like, I noticed the problem with the 1224-volt one I got was that it has very small range to adjust the brightness of those LEDs. I'd like more fine control. Meaning I'd like a broader range. All right, Nicholas. You have a great day. I like my victims happy. Man, I wish I knew more about electronics. Maybe LED driver? See, I have these, and this does work. But this can't handle, this can't handle the kind of power I'm talking about with the hat light. I'm talking about, upwards of, well, I guess I need something more like this. 40 watts, but I need something adjustable. See, this is 8 to 24 volts, 20 to 40 watts. I need 3 volts, 40 watts. Let's do 4 volt. I think it's a 4 volt LED. See, that's only 3 watts. High power, constant current, step down LED driver board. It does not look adjustable. It's also too high power. See, 4 to 27 volts. I'm running at 2 to 4 volts. I might have to hit a Reddit forum and ask. I'm probably going to need a variable resistor, a potentiometer. I wish I had one so I could try it, so I don't have to waste the money to order it, wait 2 weeks for it to come in, just to find out it's not going to do what I want. Dimming without flicker. So motor speed control is also a dimmer. See how it says LED dimmer, but also says motor speed control? So they are the same thing. But see, this is 12 to 80 volts. I need something that's much, much finer. I need 2 to 4 volts. The only thing I could do around that would be to run them in series with a boost converter, and then, but you're wasting so much power doing that. I mean, I know how to do it. I could do it with 12 of these. Actually, I know I could run these in pairs, so I could do it with 6 of these, but that would require soldering up 6 of these fuckers. And I don't want to do that. It actually would require 12 because I would need one for high power, one for low power. But I can run them raw dogging for high power. Since I'm at 3.65 volts at full charge, I'm below the threshold for the LEDs, so I can't overdrive them. But damn it, soldering up 6 of these fuckers? What a pain. It would be such a pain. Even these have a limited range, 2.8 to 6 volts. But with an output power of 9 watts, I can't put more than 2 on each one. Actually, I can. I can. Oh. I might be able to get away with running 6 of them off of one driver. Because I realize it doesn't have to be adjustable. I just need a high and a low. And you can adjust how much the low is. So basically, high power would be fixed at just max power. And then you could tweak how low you want the low power to be. And then once you seal it up, then your switch will switch between high and low. Then you'd only need 2. I might even be able to get away with running all of them on one. I wonder if that would work. It's constant current, so you're not going to overpower it. Then you just adjust it until it's real dim. It's interesting. Running each of them at less than a watt, which would be fine. I would want the whole thing to run at like 4 or 5 watts. Because at 4 or 5 watts, I can get 20 hours of runtime. Ooh, interesting. This just might work. Ew, that's expensive. Yeah, see? 10 of them is $555. 20 of them is $17.78. So I could buy 30 of them for less money than buying 20 of them. Isn't that just messed up? I hate when it does that. Two of those. I need more of these too. I think I already ordered more of these. Yeah, I did. I ordered 12 amp ones. Yeah, I think I could do that. Think about it. Think about it. And that also would require no modification since the drivers would fit inside of there. They just sit inside here. I'm already set up to do it too. Okay. That'll work. Oh, I also have parts coming in. I finally ordered the 2x10 watt Bluetooth speaker module because I want to make my own Bluetooth speaker powered by these batteries, powered by this giant battery. And I also ordered the parts to make a kitchen scale. The kitchen scale is going to be dual function. It's going to have a USB-C port to either power it directly by USB-C or you could put a battery in it. It's kind of silly to put one of these gigantic batteries in it, but it'll give the scale some weight, and it'll also mean that I won't have to recharge it for like 10 years. I can literally run that scale for 10 years, and maybe in 8 or 9 years I'll have to recharge it. So the only reason I don't use smaller lithium iron phosphate batteries is because I can't find a charging circuit for them for a 1S configuration. Let me try again. 3.21S BMS. So these here, problem is the smallest is 7 amps. I think I found a 3 amps. What I need is a 1 amp. 3 amps is too much for a single cell. Let me show you. Actually, Amazon. Asshole. Asshole. Really? They have no 18650s. What about 14500? Okay, we got 14500s. I mean, this would be ideal for running off like these batteries here. These lithium iron. Here's a 4-pack of them, $12. The problem is I have no way of charging these. I don't. There's if I put 3 amps into this battery, it's gonna burn it. It's gonna kill that battery. This gigantic battery, no problem. This thing, I could punch 40 watts into this thing, and it doesn't give a shit. But these little batteries can't handle that. And for some reason, I found some 1 amp charge circuits, but every single one that I found is not available. And I don't know why. They're just not available. See, all these here that are designed to charge single cells, they're for lithium ion. And I don't want to use a lithium ion battery because they don't last very long. Well, here's a charging protection board. But here's the problem is that it's charge only. And I also think 2.4 amps is too much. It's not a full BMS, it's only 1/2 of the BMS. This is designed to charge big cells. You know, the big like shrink wrap cells, the big packs. It's not designed to charge single cells. Single small cells. Like that. $12 amps. See, I can get away with using the 12 amp for my flashlight because I'm using a C40 cell, which can handle the maximum you're going to get out of a 5-volt charging circuit is 5 amps, 5 or 6 amps, just 25 or 30 watts, which a C40 cell can handle. But this cell cannot handle a 30-watt charge. It will literally explode. It might not explode, but it's going to be a very, very unhappy battery. It's going to be one pissed off battery. Well, find it for me. If you know where to find it, I can't find it, Medic. I've been searching for months. And I can find a 1 amp one, but it's never available, ever. It's always out of stock, no matter what. The only way I find lower current is if I do like a 4S, 5S configuration, which I don't need for these devices. I don't even need a 2S for this. Just a boost converter to get me the 5 volts I need is good enough. But they're always super high powered. There's these little round ones that are available. Well, they're not available. The lithium ion version's available, but not the lithium iron version. Let's go free shipping. Tired of seeing crap that has shipping added to it. See, 4.5 amp, 10 to 30 amp. Why do you do that? I don't fucking want you to do that. I don't know why it's so hard to won't let me click it when you sucker. Now what is that typing? Is that an O or a 0? It's an O. How about we do a search for 1 amp? Nice. Yuck. Oh, yeah, yuck. Nice. Disgusting. This is all for... No, that's not going to work. I need to have the 1S in there. I'm going to get all these multi-battery chargers. Nope, that's a balance board. 4.5 amp is the smallest. These go down to 3 amps. .5 amp. What does this do? Let's see here. So what exactly does this do? Does this work? So it'll stop overcharge but not discharge. So it's not a full BMS. This is just a balance board. It's for balancing while charging. Not what I need. What I need is this, but lower power. Seven amps. High. 12 amps too high. So again, these are designed for gigantic batteries like what I'm using. Designed for these big C40 batteries and prismatic cells and stuff like that. Not designed for tiny 14500s or 18650s. I mean, even a 21700, unless you bought a high quality 21700, struggled to handle 3 amps without becoming very unhappy. 0.5 amp, still too much though. I found little round ones like this that go down to 1 amp, but the lithium iron version is never available. It's always out of stock. I wonder. Jesus, 24 amps. That's a lot of punch. I see something like this might work. But it's designed for solar panels. It says 5-volt, 1 amp. It's very expensive. $2 a piece. Usually get it 10 for $2. But I don't see how this is a proper protection board. So if the battery connects here and your input connects here, yeah, ground and voltage in. So this is your 5-volt in. This is your battery. Where's the load go? So this is just a charge controller. This is strictly charge. This doesn't handle discharge. Well, no, that won't work. So I can't bootstrap it. I was thinking I could use this to charge it. So the USB input would connect to here, battery would connect to here, and then the battery would also connect to the BMS, and the BMS, this over here, and then that BMS would be the go-between for the for the load. But the problem is, if you ever unplug the BMS, the whole thing turns off and you have no way of turning it back on again. Because you have to put power into the BMS to bootstrap it to turn it back on again. Which for the flashlight's easy, you just plug the charger in. But if I'm using it as an internal hidden gadget, then you won't know that and you won't have any connection to it. Yes, I'm looking for a full BMS. I'm looking for this right here. I'm looking for this, but 1 amp or less. See, charge and discharge. So you have your battery connection and your power connection. So I'm looking for a full-on 1S single cell BMS for lithium iron phosphate. I can find these easily for lithium ion. They're available all over the place. What the hell is a TP5000? Might as well have spoken Greek. 5000. TP5000 charge module. Oh well, that's the problem. That's just a charge module. That doesn't handle discharge. That's not a BMS. That's just a charge module. What's this? This is for lithium batteries, not lithium ion. TP5000, LIFE4. These are very expensive. All right, 4.2 volt, which is lithium. Need iron. Oh, this one's 3.6 volts. That's lithium iron. Charger module. Yeah, see, this is charging only. So it's not a BMS, it's just a charge controller. And yeah, see, that's just a charge control. I need both. Charging management. Both. 4.2. That's lithium. That's lithium ion. Raw lithium ion. Showing you my. Yeah. Yeah, these are just chargers. I need a full BMS for charge and discharge because I'm running LEDs. It's possible these LEDs can draw the battery below its minimum voltage, so I need that discharge protection. BMS I'm using now will cut off at the minimum voltage, 2 volts or 2 volts or something. See, when you're charging, big batteries like this, prismatic cells and stuff like that, that's typically what people are doing, and that's why they have such high amperage. Most people aren't using like this here 26700 cell. That's a lot of money. 3 amps, too small, or too much power. So they have plenty of 1S boards available, but they're all high power boards. Now, I imagine, it'd be crazy for a project because it would just be too much work. But I imagine it should be possible for me to replace these MOSFETs because I noticed that the difference is these MOSFETs. So I'm guessing that these things control the output power. So I should be able to replace those with something that's lower power, but I don't know how to do that. I physically know how to do that. I don't electrically know how to do that. I'm guessing if I had something like this. Well, no, it's that LiFePO is usually used for applications where you either have multiple cells together, which is why 4S and 5S are very common, or where you have very large cells like this, where where pushing 3 amps into this is nothing. This doesn't care. I push 6, 7, 8, 9 amps into this and it doesn't care. But when you have a tiny battery, well, it cares. It cares a lot. Um, I imagine in theory I could replace these two MOSFETs with something else, but how would I know what to replace them with? I don't know. I don't know what to do with that. I wouldn't even know where to begin. I gotta find a forum where people talk about this stuff. But I also can't have a handmade solution. I have to be able to buy the component in bulk, or it's not a project that people can do. Ooh, 30 amp hour. That's a bigger battery. I could go with something like this, use a battery big enough that can handle 3 amps. Like this 6 amp hour battery, that would be a 0.5C charge rate, which this battery should be able to handle. Yeah, it says maximum 50 amp continuous discharge. Wow. And no wonder it's $11 for one of them. Better off getting the 4. That's only $7.50 a pop. It's $8 a piece for that, and less than $8 a piece for that. So even the two is a halfway decent deal. Now I could do that. I could go with a 32700 cell, which can if it can handle a 30 amp continuous discharge, it should be able to handle a 3 amp charge. So just use a different battery. That's still way more than I need for some projects, though. Like a kitchen scale, this would run your kitchen scale for a decade. You know, 6 amp hour battery for something that you're going to use once or twice a week if you're lucky. But it would solve my problem. So I might add this to the cart and add it to my next order. So let's do 3 amp. And there you go. 3 amp BMS right there. That's 10 of them for $2.52. Here's 40 of them for $6. All right, do I need the green or the blue? The properties of the lithium iron is that they don't wear out in 300 cycles. They'll last forever. They'll last longer than you'll be alive. That's why. I'm tired of disposable crap. I also don't like the idea that, you know, lithium ion batteries can blow up in your house. You know, I mean, so part of that is overblown, but they are somewhat dangerous. Lithium iron is far less volatile. Oh, those okay, 3.7 volts. So I do need to. So there, I can get those BMSs cheap, $6 for 40 of them. Let's see if there's any cheaper batteries available. It just sucks to pay almost as much for the 32700 as I do for the C40. It's just a lot of money to pay for that battery. Unless I can find it cheaper. So $4 a piece. That's not so bad. It's not 8,000 milliamps. That they're lying. It's highly unlikely that that's it. 8,000 milliamps. That's not so bad for price. That would let me make it a lot smaller. That would let me use a 3 amp BMS. This should be able to handle. Well, actually, the spec should tell me. Input charging current, 3 amps. Yes, this will handle 3 amps. Okay. Okay. That's interesting. So I can use the simple USB-C with the 516 pull-down resistors directly into the BMS, and then the BMS directly into this. And $4 a pop is not bad. Get them cheaper? No, still $4. So it's $4 no matter how many I order. It's 48, still $4. It's 10, that's still $4.30. So they're pretty rigid on the price for these things. So I could just order 4 of them and that'd be plenty. Are you telling me that it's more expensive to order 4 is to order 1? They sometimes do that, by the way. Chinese will sometimes do weird shit like that. 17.52 divided by. Yes, it's more expensive to order 4 than to order 1. Is that fucked up or what? Because this is $4.38 a piece. But if I order 4 of these individually, it's $4.31 a piece. Why do you do this? Why? Why? Oh, why do you do that? $4.13. So it is a little cheaper if I order 20 of them. Oh, I hate when they do that. How much for 8 of them? 34.76. 8. $4. It's more. Ordering 8 of them still costs more than ordering 1. Hey, DeWitt. Yeah, sorry I missed you yesterday. My neighbor fell off his scooter at 3 o'clock in the morning outside fighting skunks under his house, and he had to crawl in his house to call anybody while it was freezing outside. Idiot. So 5 o'clock in the morning, I had to go over and help my neighbor. So by the time we were done getting him back on his scooter, I was exhausted. Oh, he's crazy. Well, I don't blame him. It's got to be driving him crazy. We have tried sealing up the holes around his house a dozen times now, and they just dig around whatever we put in their path. They want to be under his house no matter what. He's got skunks under there, and you can't find anybody to hire to get rid of them because nobody wants to mess with skunks. I was tempted to shoot it because it's come over to my property a couple of times, but I just can't bring myself to do it. Thing's so fucking cute. Hey, Alan. I might be switching to a different kind of battery for some of my other projects. Because for some of my projects, the C40 is just too damn big. It's just fucking huge. It's a big freaking battery. Like I want to make a kitchen scale, and I want it to be a forever kitchen scale, and the just seems so big to use the C40 for that. But the problem is I can't use like a 14500 or a 18650 because they can't handle a 3 amp charge. Well, you can make a pen light. It just won't be a pen for your hands, you little dwarf. It'll be a pen light for the Green Giant. Uh-huh. Or what's Goliath? You know, no, what was the David and Goliath? Yeah, so it'd be a pen light for Goliath. um, but I found these cells, 32700s, 8 amps, for only $4 a piece, which is for the smaller projects is still a shit ton of power. But the price comes down to only $4 for the battery. And actually, if you decide to order these, only buy them one at a time. You know, the 20 pack is cheaper, $4.13 a piece. One of them is $4.31. If you buy 4 of them, it's $4.38. It's like, what? If you buy 4 singles, it'll cost you 28 cents less than buying a 4-pack. I'm not making this up. I swear I'm not making this up. It's Chinese math. It's like, come on. Oh, what are you gonna do? Rid of that one because that one's too expensive. But yeah, I'm gonna because I want to make other things. Like I want to make a kitchen scale. I want to make the Bluetooth speaker, although the Bluetooth speaker I want to run on the C40 because I want that to run forever. And I also want to, again, I want to make a smaller flashlight that still uses these little square ones, but I want bigger batteries, so 8 amp hours would be perfect. Yeah, 8 amps for a little single 4-watt flashlight, that's still going to run a long time. That's 8 times 3.6 or 3.2 on average, 24. That's 24 watt hours. So a 4-watt light will run for 6 hours. I think I'm okay with that. I think I'd be perfectly okay with that. And this would be far more compact. What kind of holders can I find? So yeah, I saved that, right? Yes, that's added to the cart. 32700 holder. I can't go smaller than 32700 though, because anything smaller than 32700 can't handle a 3 amp charge rate. And that's the lowest 1S charger I could find is 3 amps. You know, the C40 can handle anything. Pump 40 watts into that, and it ain't gonna give a crap. But the a little 18650 or 14500 cell, it'll blow up if you pump 3 amps into it. Or at least, even if it doesn't blow up, it'll be very unhappy. Are there no battery holders for the 32700s? Really? There's no cell holders? Huh. There's only pack holders. Interesting. I mean, it'd be easy enough to print one, but still, I'm surprised there's no cell holder available for 32700s. Wow. Battery holder single? There we go. That's for 26,650. I need that for the 32,700. I mean, easiest thing to do would be to have a cylindrical holder. Then I don't have to worry about it. Just put a spring in the end of it. But I would love to get a simple, you know, like this, but for 32,700. Huh. They really don't make one, huh? Or if they do, it's just not easy to find. I also want to what's the max discharge rate for this? The other ones were more expensive, but they could discharge at 80 amps. What's this one's max discharge rate? 30 amp continuous discharge. That's not a lot. That's only 3 times 30. That's only 90 watts. So I would need the 8. Even the 8 might not be enough. I also want to make I want to make a I can't do it anytime soon because I don't know how to do the electronics part of it, but I want to make I want to make a tool battery. I want to make a DeWalt tool battery that uses lithium iron phosphate batteries. Now, I might actually be able to get away with that for my day-to-day tools. Things like fans, flashlights, the little 1/4-inch drive impact driver, the regular drill, all of those aren't going to be a high power application. I might not be able to use it on something like a circular saw or a reciprocating saw. But for everything else, this might be enough. Because I'd like to make my own DeWalt battery that uses lithium iron phosphate, so it's a battery I never have to throw away. Now, I also heard about these other batteries called LTO batteries, um, that apparently have like a 3,000 cycle life. Yeah, apparently this LTO technology, lithium titanate, has a very high cycle life. Jesus, 45 amp hours. That's a big battery. Careful, cat. Don't hurt yourself. All right, what are the specs on these things? I didn't know any regular lithium technology had that kind of cycle life. Okay, so one of them is, oof, $35. That's an expensive battery. I mean, it's 45 amp hours, but still, it's also only 2.3 volts. So it's very low voltage. Wow, might be interesting to make a car battery out of this. 10C rating. Woohoo! 6 of them would get you your um, nominal 12, 13 volts. Nominal 2.3 to 2.9. 20 amps, 0.5 C. Discharge cutoff 1.5. 10C maximum discharge. Now that would be 45 to, that's 450 amps. Wow. So if I did 12 of them, you'd have 900 amps. Woohoo! Doesn't say anything about cycle life. 25,000 cycles. Yeah, I heard it was some crazy high number. So why don't we use more LTO batteries? And they're good for minus 40C? What the fuck? Why don't we use these batteries in cars and shit like that? I don't get it. Why aren't we using these batteries if they have a cycle life that high? Oh, that's why. 79 watt hours per kilogram. That's why. The battery pack would be huge. Okay, that's why they don't use them in cars. You would need a battery pack 3 times the size, or you'd have to accept the range of 1/3 the range. Because instead of 300 watt hours per kilogram, they're only getting 79 watt hours per kilogram. Now, granted, larger cells would probably be a little bit better, but I'm guessing that the low power density is why um, they don't get what they want. Yeah, this is 66 millimeters wide, 160 long. I'm guessing that's the dimensions. But man, the specs are incredible. I mean, minus 40C to 65C, so it has no problems with temperature. Cycle life of 25,000 cycles. It's a pretty big voltage range, but not that bad. Apparently, it doesn't go crazy when it gets punctured or cut or shot with a gun. Why would you be shooting a battery with a gun? Wow. This seems like a great solution for home power, though. Why isn't LTO more common? What's up with that? I don't know how real that is. Remember, sometimes they lie about how much power these things have. And the smallest one I found so far is 6,000 amps, 6 amps, which is it's irrelevant at that point. It doesn't matter anymore. It's big enough to do anything we want. This is the 6,000 buds here. They're $11 each. Well, they're $8 each. It's $11 for one, but it's 16 for two. So they're $8 a piece. But for half the output capacity, this is half the price. I'm okay with that. Oh yeah, right here. Let's see, 11.61 for one, 16 for two. So yeah, these are also $8. Actually, much cheaper. Four of them is only 21. That's 5.40 a piece. How much is 10? $5 a piece. You can get them for $5 a piece. That's not bad. Yeah, you might as well get the 12.8. Only 30 amp. 30 amp is fine. 55 amp spike, 30 amp continuous. Well, that ain't bad. I'm gonna save that one too. And you can get it for less than $5 a piece if you order 12. It dips just below $5 each if you order 12. So yeah, you might as well order 12 at that point. So let's remove that and let's add the 12. What I might do is order one at $4.31 just to play with. Then if I decide I like them, then order 12. This guy. Wow. Yeah, I'm okay with that. Let's see, 145 grams. Cycle life, more than 2,000 times. Standard input charging current, 3 amps, so we can use the standard 3 amp BMS that is available. So that's not good. It says here, continuous discharge 55 amps, but up here it says continuous discharge 30 amp. So be careful with that. Don't go over 30 amps. 55 surge, 30 amp continuous. As is typical, they do not like charging below 0. Hey, fuck yeah. It's 32 millimeters by 70 millimeters. It's still a pretty big battery. How big is this one? This one's 41, so it is a lot smaller. It's 25% smaller than this one in diameter, a whole lot smaller in length. This is 140 without the tabs. Well, that one's 70. So yeah, it's like 1/4 the size. Okay. I'm definitely going to want to mess with some 32-700s. Oh, here's some more 12-800s. Is that? Okay, so it's $10 a piece if you order that many, and it's $7 a piece if you order 10. So the other one's cheaper. Yeah, this is the cheapest one. 12 of them for $60. Not bad. Well, is it better? No. Yes. Yes. No. That's the correct answer. It's yes and no. 50 amp is different than 30 amp is the correct answer. As far as what does that mean to you? How many amps are you going to draw? If you're putting this in a flashlight, it fucking doesn't matter because you're drawing a maximum of 1 or 2 amps. So for a flashlight, what would be more important is what is this number here? 12,800 versus 8,000, because more milliamp hours means longer runtime. So the way to think of this is, again, it doesn't matter. It's irrelevant. It depends on what you're doing. So you have power and you have energy. Power is how quickly you deliver energy. Energy is how long can you deliver power. So if you have a device that requires 1 amp and you have a battery that has 1 amp hour of capacity and it's able to deliver 1 amp as a standard, then it can run that device for 1 hour. Because you have 1 amp hour and it can run 1 amp load for 1 hour. So in this case, 30 amps means you can discharge at 30 amps. What does that mean? Well, let's just call it 3 volts to keep, it's actually a little higher than 3 volts, but let's call it 3 volts to keep the math simple. You have 30 amp hours, always convert to amps. So 30 amps, 3 volts. 3 times 30 is 90. That's 90 watts. You can pull 90 watts from that battery continuously. Now a 50 amp hour battery is, if it's able, not 50 amp hour, a 50 amp discharge battery is 50 times 3 or 150 watts. So if you have a device that needs 30 watts of power or 60 watts of power, such as my hat light here, it's going to draw 60 watts. Well, 30 amps times 3 volts is 90 watts. That's more than the 30 watts that I need, so the battery is good. There'd be no point in spending more money on the 50 amp discharge since the 30 amp discharge is already more than what I need. Now, if I were to plug in 2 of these into one battery, well, that's 120 watts. That's more than 90 watts. So now the 30 amp discharge battery is a problem because it might overload trying to power 2 of these. However, the 50 amp discharge battery can pump out 150 watts, which is greater than the 120 watts that 2 of these need, which means that battery will work okay. So what you need to figure out is how much power do you need? Not how much energy do you need, how much power do you need? That's where you need to know the continuous and surge discharge rating. That's why a fridge is, it needs a surge for that compressor to turn on, but once that compressor's on, it's very low power. So as long as you have enough of a surge rating to handle the compressor turning on, you're good. But with the devices that you and I are running, power consumption is pretty continuous. There's not really much in the way of surge. So you just need to know how much power does your device require. Well, At 4 volts, this is 5 watts. So let's assume the worst case scenario. Well, again, I don't think that's a 50 amp continuous discharge. Description says 30 amp, 50 amp, which is a 30 amp continuous, 50 amp surge. So I would assume it's 30 amp, not 50 amp. Just be very careful with that rating. But even still, unless you're running some really, really high-end LEDs, you're not drawing 30 amps. So you got plenty of power there. It's probably not going to draw 60 watts because these are 4 volt, I think, and I'm only giving them 3.5. So these are probably only drawing about 3.5 watts each. Hey, Michelle. There. See them. They're both curled up right here. There they are. Here's our babies. All curled up. Sorry, baby. Woke them up. It's a good. It's a good boy. Yeah, not bad. $4 a piece. I'm okay with that. $4 or $5 a piece. Hell yeah. The whole reason I went with the C40s. Well, there's 2 reasons I went with the C40. Well, okay, there's 3 reasons I went with the C40s. Okay, so reason number 1, it's stupidly big. Just because. Reason number 2 is I wanted to run a very, very long time. And reason number 3, it's got the screws on the end, which meant wiring it up was very easy. 2 M6 nuts and you're done. With the 32700, you're going to have to devise a holder to hold that battery. You're going to have to figure out how to print or buy or manufacture a holder to hold the battery. Not that hard, but not as easy as just screwing 2 M6 nuts into the flashlight. And mine came with the nuts. So I didn't even have to buy them. Yeah, they're nice. The C40s are nice. And plus I knew they can handle the charge rate of the charge controllers. So like I said, the my little USB power bank, I love this thing. I use this thing almost every day. It's just wonderful because I can plug in 2 chargers simultaneously, and so I could charge this at 40 watts. That means I could charge this in less than 90 minutes. It's nice. And the other cool thing is this end here, this screw-on end with the USB thing in it will fit the flashlight. So the next thing I want to do after I finish the hat light, I want to print another one of these to put on my flashlight. So my flashlight can also be a power bank. Yeah, I'm very happy with it. I love this. This is nice. This came out nice. And if you only use one end, you just use a blank cap on the other end, the power meter will be accurate. It'll accurately tell you how much power you have left in the battery. If you use both ends, they lose accuracy because this one has no idea what this one's drawing, and this one has no idea what this one's drawing. Now, the good news is the overcharge protection and the over discharge protection works no matter what, irregardless of what is on that display. So you don't have to worry about that. It just won't be accurate. Like I can drain this down to 1%, and this one will still say 100% because it doesn't know. It doesn't know that the power's been drawn out from here. Yeah, this I love. I love this. It's just and easy. It's an easier print than the flashlight. Just you got the 2 covers, the 2 caps, and the body. That's it. Oh no, and the washer and the thing inside here. But it's a super easy print and easy solder. 4 solder joints. Well, if you do 1 cap, 2 solder joints. It's so easy. Yes. Yeah, these boards have they have full BMS support. So they have overcharge and over discharge protection built in. You do not need to use the little 12 amp BMSs that we were using. You don't need those. This board supports that. The only reason I can't use that board for the flashlight alone, meaning without the other board, is that there's no battery pass-through. There's no pass-through on the BMS on this. So there's no place for me to plug in my flashlight LEDs unless I plug them into the USB 5 volts. I don't know how it'll behave if I do that. Nice. Damn, boy. Yeah, if you want to keep it simple, just use one. The download comes with a blank cap for the other end, so you don't have to use the power cap on both ends. And then you can make 8 of these using that power board. And that'll give you 22-watt input-output bidirectional USB-C. And it's super easy. You'll need 4 M2 screws, the 4 little M2 screws to screw it in. Trick is to make sure you use the pointy ones. That's why you were having trouble getting your screws to go in. You need to use the ones with a point. And this is the most of the big screws are this. See the modified truss head? And it's a number 8. So most of them are 1/2 inch number 8 truss heads, except for the 4 that go into here. Those are 1 inch number 8s. The holes are already pre-shaped for them and everything. Just screw them in. 1/2 inch, 1/2 inch, 1/2 inch. These are all 1/2 inch. So you need 6 1/2 inch and 4 1 inch. Number 8 modified truss head screws. They're not. If they're number 8, it's what you need. They look like they're too big. They're not. They screw right in. You can see it. They screw right in. Right? The holes are actually threaded. The holes are actually 3D print threaded. So they're designed for it. They're a little snug, but you want them snug. As long as you're using at least 3 perimeters, you ain't gonna crack it. But yeah, they're number 8, which is 4.2 millimeter. So it's M4.2. Yeah, number 8, 1 inch. It's like that. But you don't want the self tapping. You want the you don't want the self drilling. You want the self tapping. You want the pointy ones. Because if you get the ones with the drill tips, then some of these aren't going to get bite in threads. See, I had to be careful here. At least this one here, I had to be very careful with. That's why this is so deep. Because I had to make sure that this doesn't puncture the battery. That'd be bad. That'd be bad, bad, bad. But if you bought that little kit, that'll get you enough to get you started. Then you just do what I do. Buy 500. So this is 500 of the number 8 1 inch truss head. And when I have some more money, I'll order 500 of the 1/2 inch. Since that's what I use the most of. Most of what I use is 1 inch and 1/2 inch. This is pretty much all I use for assembling 3D prints because the modified truss head spreads the force enough that you don't pull through the plastic. Yeah, it should work fine. Any TPU you want. You don't even have to use TPU. You can print this with regular plastic. The problem is if you drop it, it's going to break. Guaranteed. That's a 360 gram battery inside there, right? Plus the weight of everything else. You drop this with the ends not TPU, it's going to shatter. But yeah, air would work fine. Yep. Fun, fun, fun. I also found that for very, very cheap, we're talking less than $4 in components, you can make your own high accuracy scale, like 1 gram accuracy scale using a load cell. And so I'm gonna buy the parts for that. I already bought them. The control board and the load cell with the controller for the load cell. I'm gonna make my own kitchen scale. Oh, it's kind of silly to use the C40 in a kitchen scale because that would literally run the kitchen scale for like the next 10 years. Like you wouldn't have to charge it for like 7 or 8 years. I mean, like literally, it would self-discharge faster than you would use the power. So I'm gonna make it run off of the 32700 cell, which is a lot more reasonable. I might come up with a use for those 45 amp hour LTO cells if I can get them a little bit cheaper. It'd be nice to make like an old school lantern. Remember the old lanterns with square batteries on the bottom? You can just like sit it on a table and crap like that. It might be neat to make an old school lantern where instead of having 2 of these LEDs on the front, I had 6 of them in a grid of 3 by 3, 9 of them. So 9 of these LEDs in a grid, and big handle on the top. You sit on the table kind of thing. It might be interesting to do that. Yeah, exactly. Make an old school big lantern and use the LTO cells. So put like 2, maybe 3 of them in there just to get the voltage close. Because if I use 3 of them, that'll get me like 7 volts with a minimum of 4.5 volts, which is perfect for USB. Then just a voltage regulator to smooth it out at 5 volts. And that would be a 135 amp hour lantern. I'd probably be better off using 2 of them. So that would be 90 amp hours. That would be 180 watt hours. You're talking battery box territory for a flashlight. Yeah. Why? Because I can. Is there any better reason than because I can? I might want to do that now. And just for shits and giggles, print the whole goddamn thing out of TPU. Like all of it, all the parts out of TPU. So you could punt this thing down the stairs and it won't give a shit. I might do that. Oh, I might have to do that now. Oh man. Do they have LTO BMSs? LTO BMS. Oh, that might be fun. Watch them not make one. That just sucked. How would I do it if I couldn't? I wouldn't know how to do it. I mean, that's not going to work. It's a different voltage range. I mean, it's a completely different voltage range. Oh boy, I'd have to figure out how to charge the thing. Like, how would you charge one of those? BMS or 1S LTO cells. Go BMS recommendations for LTO battery. Damn. Looks like a similar problem. Nobody uses these for gadgets like like us crazy people want to do. So there's just not much available for it. Oh man. So what's this? Open source lithium ion. That's the cool part, is being able to charge them below freezing too. Which means for a camping lantern, that'd be perfect. Hey, dumbass, it's the same fucking thing. Oh, there's the wink wink. Huh. Yeah, the low power density is why they're not super popular. That's too bad. A sodium ion BMS might work. They have very similar voltage ranges. At least it might work well enough. You know? Might have to look into that. I definitely want to play with the 32700s though. So as soon as I have the money, I'm going to order a couple of those. Play with. Especially since I know they can charge at 3 amps. That'll allow me to make smaller projects. Oh, here's a 2.5 amp. Really? You're going to charge $5.60 for a 13-cent board? That's about what it's worth, too. Give me a... Although, no, that's 3.7 volts. That's not lithium iron. Yeah. That also say? Yeah, that's a 2.5 amp, too. Let's see, 100? $16 for 100. $17 for 100. Which is 17 cents a piece? Yeah. Why aren't you showing me all of them? How much for the other ones? Oh. What about 26,700? 26,700. Oh, wait. 21,700, I think it was? Yeah. That'd be even smaller. Was it 21,700 or 26,700? I think it's 21,700. Isn't that what they use in the new? Yeah. No, that's a 32,700. Might not have any. You can get it like this, so you can buy a big pack of them, but I don't want a big pack of them. I want single cells. Because that's what the tool batteries use. Really? You can't buy 21,700 lithium iron phosphate cells? I know they make them. They use them in electric cars. 32,700. It's 21,700, but I think it's lithium ion. That's definitely. Well, there's some 21,700 lithium iron. $26,650s would be good. It's a 32,700. Here's a 26,650. Interesting. Come on. Load the damn page already. Jeez. And 3,500 milliamp is plenty. How much is 4? Ooh, they're a little expensive. 17 by $8 a piece. $7 at 4. Still not loading. $6 a piece if I get 10. It's not horrible. Specifications. Still loading. Continuous discharge 5 amps. That's plenty. Cycle life at 2C 1500 cycles. It's not great. Still pretty high. Continuous discharge 5 amps. What is the charge rate? No maximum charge. Can it handle? It has a built-in PCB protection? Huh? Typical fast charge current 6 amps. So we can charge at 3 amps. Okay. These are expensive, but I'm going to add them to remind me to look for cheaper. Okay. Because this would make it even smaller. It's only 26 millimeters by 65 millimeters. So this is actually a pretty small battery. 21,700 would be nice. I would love to use an 18650 lithium iron phosphate battery, but I can't find any. Oh, of course. It would make a mockery of me. It would make a mockery of me and show me 18650 lithium iron phosphates. Asshole. It comes up right away. Oh, seriously? You douchebag. And they're cheap. 4 of them for 11 bucks. How much is 10? 20 of them is 40. Means 10 is 20. That's $2 a piece. Yeah, that I can afford. Now, question. How much power can they? Really? You give me a hard time, aren't you? Why are you running so slow? Show me the deets. Not the specifications. Is it still trying to load, or? Come on. What the hell are you doing? Kill some of these other tabs. Okay. Go. Oh, you're not going to show me anything, are you? What? What's the limits? I have no idea if this can handle a 3 amp charge rate. That would be a 2C charge rate. That's asking a lot of a battery, actually. $3 a piece of order. Ooh, standard charging current 0.2C. That's not good. It's 200 milliamps. Is it? 1C would be 2 amps, right? Yeah, because 3C would be a 6 amp discharge. that's no good if it can handle 200 charge rate. If it was 18650, it'd be nice. That'd allow me to make it compact. I think that's charge rate. That's 0.2C. Oh well. 32700 is a better deal as far as watts per dollar, but it just means that it'll have to be physically larger, which is kind of annoying. Okay. Alrighty, I'm gonna get um I will see you guys next week. Yeah, 3:30. I'm gonna start soldering. I finally got some solder, so I'm gonna start soldering up. Oh, I wasn't even showing the screen. All that time I'm just, oh, I hate that so much when I do that. But I finally got some more solder. Start soldering up these hat lights and see what I can do to make it right. I want to work on a lantern though. If I could figure out a way to, I could use a couple of the C40s if I have to. Like a pair of the C40s would work. Um, but I'd like to go with those 45 amp hour LTO cells just because they're so goddamn big, and you can charge them when it's 40 below zero. I just want to. I don't know why. I just want to. I want to make. I want to make a big, goofy, honking, old school, lantern. It looks like an old school lantern, but 9 of these freaking emitters on the front. There's 9 of them all facing forward, just boom. Just light up a whole fucking area for a couple of days. So I might work on that just for shiggles. Now maybe I'll design it so they can run off of its own batteries or run off a tool battery. Um, yeah, actually, the tool battery would work. The 6 of those lights will run off of a tool battery. Um, but the problem is tool batteries are both expensive and don't last long. But then again, for this kind of a flashlight application, do you really need that kind of long life? I mean, because it'd be super cheap to just be able to stick one of these in there. In fact, the other one I have, it's over there. You can get DeWalt batteries and probably the other companies too, with a built-in bi-directional USB-C port. So I can buy a battery off Amazon. Show you. Why is it not showing me the battery? Why isn't it showing me the battery? I bought them. Yeah, something's wrong with the fact that it's mostly showing me Vault products. Battery. Why isn't it showing me the batteries? Something's wrong. There. Now, why wouldn't that come up in search? USB-C, DeWalt. Oh, it doesn't say 65 watt. Ah, okay. Well, anyway, I bought this battery. Oh, it's currently unavailable. That's why. Well, that sucks. I have to get it off AliExpress. But anyway, I bought this battery for my DeWalt, and it's got a built-in 65 watt hour USB-C bidirectional port. So I can output 65 watts and I can input 65 watts. It's fucking amazing. It's awesome. I love it. They need to pass a goddamn law that makes it legally mandatory that all battery manufacturers include a bidirectional USB-C port in their batteries. It's just stupid that they don't. Now, why isn't that available anymore? It's such an awesome battery. Boy, that's BS. I mean, sure, you can get USB-C chargers, but I would rather just have it built into the damn battery. There we go. There's another one. Maybe it's because they changed design, because that looks like the same battery. All right, there it is. 65 watt, 40 bucks. For 40 freaking dollars, you get a 6 amp hour battery that has a built-in bidirectional um, USB-C port. You just can't beat that with a 10-foot stick. My batteries category. I have a battery section. Power tools. That's awesome. I love that. I wonder, do they have a Ryobi USB-C? Ooh. 100-watt charger. Nice. And it's clear. Just freaking awesome. Why is this one so much cheaper than this one? Two-way USB charger with OLED. Nice. 100-watt fast charging. It can output 145 watts. That's just badass. That later when I can afford it. I can't afford it right now, but eventually. Let's see. M18 USB-C. That's output only, not input. Here's an input, but it's not a battery, it's a charger. Eventually, I'll probably get one of these for all the different battery techs, so I can just charge everything by 100 watt. So I think these are 65 watt. Huh. About M12. So there's an M12 charger. It's a relatively slow charger, I think, but it is an M12 USB-C charger. that says fast charging, but I don't know how much that means anything. Oh, they make an official one. Nice. What I would really like is actual M12 batteries with a built-in USB-C port. And you don't have to dick around with these stupid adapters and shit. Just take the battery out and plug in a USB-C cable. All right, that's it. I'm done. You have a super week. Hopefully I'll remember to chime in on Sunday and watch you on Sunday, DeWitt. Sometimes I fall asleep first. But yep. I'll see you guys next week. Be good. Happy victims.